Hey everybody, and welcome back to this fourth tutorial on the Agent Development Kit. If you recall in last week's tutorial, what we were able to do was to use ADK's API server to serve our agents via endpoints. There's quite a lot of endpoints, which is very useful, but can also make it quite complicated. So today I'll be showing you how you can simplify your agent to just 2 endpoints. I'll be showing you how you can use Postman to test your agent's endpoints as well. I will also be providing you with a custom front-end application to interact with your agent, but this time your agent will be run against just this one endpoint. And the benefits of doing it this way is that you can actually provide a much cleaner and simpler interface for your agents. We will also be making our agent agent-to-agent or A2A compatible. This will allow you to conform to Google's A2A protocol, which is being adopted by an entire ecosystem of developers. Just like how MCP has now been adopted by multiple AI companies, A2A is also being adopted in a very similar way. So you do not want to miss out on this. At Google I/O this year, Google are going all in on AI. And yes, that also means going all in on AI agents. One of the latest releases from Google themselves has been the Agent Development Kit. Now they've officially announced version 1.0. This means that it's feature complete, stable, and ready for you to actually launch into production and start building your agents using the Agent Development Kit. So if you've been following this series, well done, you're early. But if not, do not worry. If you haven't already subscribed to the Insiders Club, you might want to do so. It's completely free. It'll give you access to a private Notion page where I post some additional material related to the course. For example, you can actually see an early preview of upcoming lessons, including full code snippets and a step-by-step guide. And what's more, I'll soon be releasing the internal GitHub repository containing all of the lessons that we've been working so far, all of the source code, and the notes related to this course. And all this material is intended to supercharge your understanding of AI agents and how to use the ADK. So head on over right now to this URL over here and join the Insiders Club. So without further ado, let's get going with today's tutorial. In case you haven't already set up the project, I'm just going to show it to you. You just clone the repository over here. I'm going to put it into a different folder because I've already got several copies of this repository. I am putting it into a folder with the number 3 at the back so that it doesn't clash with what I have. Great. And then once you're in it, you can change your directory to go into it. The first thing you want to do is to make sure that you have your Python virtual environment set up. So you do Python -m vn. This will ensure that everything that you have in your project is going to be kept within a virtual environment. Then you do source vn bin activate. And as you can see over here, this means that you have activated your virtual environment. When you do which Python, you can see that it's going to use the Python that's within the ADK made simple.vn directory. This proves that you're not going to mess around with your system's Python installation, which is very important when you're trying to make sure that all your dependencies do not clash with one another. All right, so the next thing you want to do to prepare for today's lesson is you want to change your branch. So you do git checkout. This will bring you to the end state of lesson 3 from the last video so that you're ready for today's lesson, which is lesson 4. This will ensure that you have all of the starting files and folders that you need. And then finally, you do pip install -r requirements to get all the dependencies that you require. I've just opened up the folder structure, so you should see it on the left here. Once it's all installed, open up your .env.example file and make a copy of this by opening it up and then doing file, save as. And then you want to just call this .env without the example. If you get a warning, just say use dot. And within this, you want to actually put in your Google API key and your ElevenLabs key that you've been using from the previous tutorials. So just a quick recap of where we ended up last week. We were actually serving our agent via an endpoint, but the FastAPI endpoint was actually generated by the ADK. And the way that we did so was to go into the agents folder and do ADK API server. But the problem with that is that it actually predefines how the requests and the responses from the API are made. If you go into your agents folder and go into your speaker agent, we had to make sure that we gave the instruction to return the result in this format over here. I've converted your text to speech. The audio file is saved at this file path. What we then had to do was in our front-end application, in order for us to get that URL, we actually had to kind of parse that response from the agent, look into a very specific portion of its response, and then we actually had to look for file saved as, and finally get the audio path out of it. This is a problem because somebody who is using your agent is going to have to do natural language parsing, splitting the text, and then extracting up the audio. What if you decide to change the way that your agent responds or which LLM you're using? Then they will have to change the front end as well. Wouldn't it be great if somebody was using your agent that you just returned the response in a much easier to understand manner? Something like the following, where the message says, I've converted your text to speech. The audio file is saved at blah. So this is the message from the LLM. But then instead of them having to read and parse this, you actually respond with the data that they require, which is just audio URL, and then it gives you the path to the file. And so the person, all they need to do is just look for the data and then look for the audio URL within the response. This is a much cleaner way. And this is the reason why in today's tutorial, I'm going to show you how you can serve your agent via your own FastAPI endpoint, in which you define how the requests are made and how the response is returned back to the user. This makes for a much cleaner agent interface, and it will enable you to create much more robust agents for your users. So the first thing you want to do is create a new folder in the root of your project and call it common. Within it, create a file called A2A server.py. The reason for this is that we create a common boilerplate for all our agents to utilize so that when we actually end up extending this to our coordinator or our Reddit Scout agent, we don't have to rewrite a lot of the code again. The first thing that we're going to do is we're going to add in some imports and a common block at the top. You're going to have an agent request model followed by an agent response model. All right. And these are the only two building blocks you really need. You define how your agents send requests to one another and how they respond to any request they get. Now, if you're getting all these squiggly lines, don't forget you can do Control-Shift-P or Command-Shift-P, do Python select interpreter, and pick the one in your virtual environment. This should help resolve the warnings that it can't find some of these dependencies because these were installed in your virtual environment. Now, the next thing that we're going to do is create a helper method called createAgentServer. And this is very simple. All it does is that it will be the main method that we'll be using to create a FastAPI server for our agent that is A2A compatible. It takes the name of the agent, a short description, and a task manager, which I will go into more detail very shortly. Create our app. So the app is going to be a FastAPI app with the title, which is the name of our agent, using the description that we pass in. The next thing I'm going to do is define a run method. The main thing our run method is going to do is take a request based on the model at the top. It's going to take a request based on the schema that we'll define over here. And then because this is FastAPI, we're going to specify body. This is just syntax to say that you get the information from the body of the request. In order for you to expose this as an endpoint, you can use the decorator. So you do @post. This means that this will be accessible whenever you send a post request to this run endpoint. You specify that the response model is the agent response that we will define over here. And this is pretty much the framework that you'll be using to create any FastAPI server for your agents. Let's go ahead and define some of these right now. There are three things that are going to be in the request. The message, this is what you would call the prompt that you'll be giving your LLM. The context here allows you to pack additional information that goes along with your message. The session ID is to identify which session you're in. This will allow the AI agent to understand what is it responding to and what is the context around the conversation. For the response, it's going to be very similar. You're going to have a message and a session ID. And again, this message would be the message that comes back from the agent. This session ID should be the same as from the request. And then the other two things you want to provide are the status, whether it's been successful or not. And finally, additional data. If you recall, is what we discussed earlier when we wanted our message to look like this, right? So we wanted to have an audio URL that would provide the path to the audio so that nobody needs to actually parse this message itself. And so as you can see, this desired response is what we are trying to define with our agent response model over here. All right, so now with those two things done, we're actually going to specify what our run method is going to look like. For our run method, we're going to call process task on our task manager, which we will define very shortly. It takes in the message, the context, and the session ID, and gives us back a result, which we will store. And then we will simply return the agent response. We will get the message and the data from the response from the agent. And then we're returning success and the session ID over here. Now, because we want to catch any errors, we should actually also remember to put this into a try except block. So we do try, and then we put this all within that, and then we capture any exceptions. If there's any exceptions that happens, we will just return a response and make sure that the status is error and pass in any information related to that. Great. Now that this is done, the next step is to create this task manager class that we specify over here, define how it processes the message, the context, and the session. So go into your speaker agent folder, create a new file and call it task manager. We're going to do the following. The first thing I'm going to do is just add in a whole bunch of imports. These are the key things that you need from the ADK, is that you need your agent, you need a runner to run your agent, and then there's this memory service and an artifact service to allow you to store information and memory within your agent. And this will become clear very soon. For debug purposes, we're going to configure our logger. And then finally, the only thing that you want to call, the other thing that you want to do is to just define an app name. And the other thing that you want to do the other thing that you want to do is just define an app name, which we will call speaker A2A app. The reason for this is that we will be making this agent not just serve from FastAPI, but we'll also make it A2A compatible. All right, so what we're going to do here is very quickly define what a task manager is going to be, and this is going to be the core functionality related to your agent. So the task manager here is going to be for the speaker agent, and the main two methods that you're going to need are the constructor. The other one, which is the most important one, is called the process task method, which effectively takes the message or the prompt from the user, the context, and the session, and then responds with the result. I'm just going to add some logging information so that it tells us that it's initializing task manager. It's also useful to store a reference to the agent being passed in over here. The next two things you need are the session service and the artifact service that we've imported from the Google ADK over here. And finally, we create the runner that we have over here. So the way you do that is you do self.runner, and then the runner takes in the parameters, which is the agent, the app name, and the two services that we've defined over here. We also want to make sure we have an output directory to store the files. If we choose to do this, we can actually specify an audio output directory. Going to do the processing of the response. Remember, this is like the core functionality that is going to be hidden from the users of your agent. This is where you're going to do the bulk of your processing, and then you're going to try to simplify the response back to your user. So in this case, the code for this, the main thing is you're going to get the user ID from the context, and then check whether there's a session ID. If there's no session, you create a session. Then you get all content related to the user role so that you can reference it later. Now, finally, we're going to focus on what is the core functionality of this agent is going to be. So I'm going to paste it here. And what this does is that you do a run async, and then you start passing in the user ID, the session ID, and the request content that came. The next thing you do is cell.runner, which you've stored here, and you run async. You just have to pass in the following three things: the user ID, the session ID, and the message or the prompt that came from the user. And then you're going to run your agent asynchronously to respond to that. Prepare some local variables that will form your response. And then here, we're going to look through, prepare some local variables. Okay. And the results that come back from running the agent, we're just going to throw it in a variable called events. So we're going to store the results of this run in an events variable. And then we're going to prepare our response. We prepare some default responses that we will return. The way that the LLM is going to be responding to us based on the agent is that it's going to respond successfully. It's going to show you, I've converted your text to speech. The audio file is saved there. So we're going to have to write the parsing of this within our task manager. So we're going to have to just look through the events that are returned from the agent and then try to extract out that path from the response. The way that we do it is for event old events. And I'm just going to copy and paste the code here because it's very similar to last week. You can see that we're going to check that only when it's the final response and it's coming from the AI model. And then we do the splitting. We look for the tilde character, which will show our path. And then finally, we extract the path. Now, you might have a question here. You say, hey, wait a minute. I thought you said that we shouldn't be parsing things from the LLM. Now, what I said is that when our agent responds back to the user, or whoever is calling our agent, we don't want them to have to unpack and We don't want them to be the ones to have to do this unpacking and splitting and delimiting and extraction of the information. We do it within our task manager for our agent itself. This is all hidden from the person calling our agent from the endpoint. This is all done within our logic. We can make this as complicated as we want to, because the main thing that we'll be doing at the end of this is that we'll actually just respond in a very... Because at the end of the day, after they call our agent, the main thing they care about is the response, not what we do within the processing. And here's the response. It's just going to give the final message, which is from the AI LLM. We're going to tell it it's a success, and we're just going to give it the audio URL, which we managed to extract for them. For debugging purposes, we are also going to give a couple of the raw events, just in case the user wants to dissect what went on. But the real thing that they're looking for is going to be this audio URL. So like I said, this can be as complicated as it needs to be because it's not exposed to the user. All they see at the end is that they get the audio URL in the response. So that's it for the task manager. And actually, we're pretty much done, because now you will see that. All right. So now that we've actually defined what the process task does, the last thing that we want to do is remember to always consider the fact that there might be an exception. So we're going to put all of this into a try except block. So here we go. Just tab it in, try, and then accept. Just in case there is a problem, we will make sure that we respond with the error and the right status and the empty data so that it fails gracefully. So now we've defined our agent's task manager. This is the core of what the agent does. The only thing that we need to do is to create an entry point for our agent. Those of you who are familiar with Python, this should not be too surprising to you. We create a main.py file. When somebody does Python -m agents.speaker, he will be able to run our agent like a Python module. All right. So first of all, start a bunch of imports from the top, and then I'm going to import the following. We're going to get a task manager, which we just defined, the agent, which is the root agent. The root agent is the one that we have over here. It's actually the agent's root agent that we have defined in agent.py over here. Remember, we created this create agent server method in common. We're going to import that so we can utilize this common functionality. Just a few things that we need to do is to make sure that we are able to load our environment variables. For ease, I'm going to create a global variable for the task manager instance. I'll have a global variable to store a reference to our task manager. And so all we have to do now is define the main method, which is our entry point. And then this is just some boilerplate code that you can use. If you're familiar with Python, this should be fairly familiar if you've used Python before. Effectively, this just allows you to run it. And this should be quite familiar to you because this allows you to effectively do something like main.py. This is the entry point. It basically looks at this as your entry point. And if you're using it as a module, as we're doing, you will see that we'll do Python -m and then agents.speaker. And this function to see what it needs to do when this is called. So in the main method, we're going to do some asynchronous processing. All it does is run the main method asynchronously. If there's any interrupt, it will end it. And if there are any errors, it will exit with an error code. So first things first, within the main method, we're going to reference the global task manager instance. We're going to await our root agent over here. And then we use the following. We sync with exit stat. First, we're going to set the task manager instance to our speaker agent's task manager just before this. And we're going to set the host and the port to localhost, and we're going to use 8003. And the reason for 8003 is that we have multiple agents. I'm just reserving this port for the speaker agent. Finally, we do app create agent server, which is what we define in our common file. We're passing the agent instance name, the description, and the task manager instance that we defined before. Finally, we just need to configure UVCon, which is the library that runs our FastAPI server. We pass in the app, and then we pass in the app, the host, the port, and we set the log level to information so that we can debug this. Finally, we set the server over here. This will allow us to run our own. This is actually very familiar if you've used FastAPI before. Ultimately, what this does is that it allows you to serve your agent via an endpoint. Now we can actually test this out. Now this is great, and we can actually test this out. This is all we need to do. Now this is all we need to do to get our server running. But remember, I said we wanted to make sure that this was A2A compatible. To make this A2A compatible, it's actually really quick. All we need to do is provide an agent card, which is effectively information about your agent. The way that you do so is very simple. And we might as well do it because when we go about testing it, it's actually going to be quite quick and it ensures that your agent is A2A compatible, just like that. So what we're going to do is create a folder and call it .well-known. Make sure it's a dash, and within that, create another file and call it agent. And within this, you just want to provide some information about your agent, which I'm going to pre-populate here. This is a speaker agent. It converts written words into speech using the Eleven added some capabilities that it does, and then just some information about who the author, which is me. We have one endpoint run in our A2A server. We always define a run endpoint. We have this agent card tells people what is your agent all about, what endpoints are provided by it, and what input and output format to expect. We return things in a JSON format, simpler, by returning our response as a JSON object, rather than the pure text string which people need to manipulate themselves. So this is great. Now, we actually return things in JSON, and that's exactly what we do now. We don't return things as a string. This gives the user of our agent a lot more confidence about how our agent responds, and it's a lot easier to manage. Finally, the main thing that you want to be able to do is to allow people to get this information. We want people to be able to get this information. So we're just going to add one more endpoint according to the A2A protocol. And we just go into our A2A server over here, right? And what I'm going to do is I'm going to call this get agent card. And all this does is locate this file that's over here and then return the information that's in agent.json. So like I said, it's just going to, and all this code does is that it basically looks into, it finds the modules, the speaker agents folder, looks into the well-known folder, and then looks for the agent.json file, and then it just returns it. And remember, we need to do app. And because we're not passing in any information, we're just getting information, we do get, and then we do, to follow the protocol, we do well-known. All right, great. So now we've actually made this A2A compatible. We've provided an agent card that gives the information and a way for people to query that information. Okay, to end this off, you have to return app because our create agent server creates a FastAPI server instance app. One more thing we should do is take this code and put it just under this code block because this inspect will wrongfully resolve the path, which will cause you problems later. So it should look like this. If you open up your terminal, make sure you are in the root of the folder and then do Python-m because you're running module agents.speaker. Remember, it's dot here, not slash, because you are not running ADK run. In this case, you're running it as a module. Hit enter and give it a second to run. You can see that it's connected to the ElevenLabs MCP and you're ready to go. Let's open this up in the browser. And if you see not found, don't worry. All you need to do is do /docs. And now you can get the Swagger UI just like before, except that it's a lot cleaner now. You only have two endpoints. One of them is the agent card and the other one is the run method. And it actually gives you examples of how you can pass in the requests based on the schema. And this is why we spend time making sure that we define what the agent request and agent response would look like. You're going to test this out straight within here before we move on to Postman. So if you go here and you try it out and click execute, you can see it's done a curl request and it's given you the agent card back. This is the same information that we define in our well-known agent.json. And just so you know, you can actually run this command within the terminal itself for convenience. So if I open a new terminal here, and just paste this, you will see that you get back the same response. All right, now let's just switch over to Postman so that we can test this out even more. Okay, so I've got Postman up and running. If you recall, our agent's running on localhost port 8003, and we had two endpoints that we defined. The first one that we'll do is that we'll run a get against the endpoint well-known agent.json. And remember, this is the agent card. All right, so if you click send over here, and you can see that it now has returned you the agent card information that we defined in the well-known agent.json file. So we know that this is working correctly, and that's great. The next thing we're going to do is perform the text-to-speech using the run endpoint. First, you put in the body, the request format defined in the agent request model. There's a message, context, which contains the user ID, and then the session ID. You can just use dummy data for now. The main thing that you want to put is in the prompt or the message is convert to speech hello A2A world. Make sure that in your headers, you put content type and then set this to application/JSON. This is just important metadata that you put into the header so that it knows how to process the request. So let's just try this and click send. It's going to send. And now you can see you've got a response back. It contains the response from the AI. I've converted your speech. Audio file is saved here, but rather than you having to extract this out, you can see in the data response something called the audio URL that already contains this. You don't have to do anything to process it. And remember that we did some debugging by putting in the raw events, so you can see some information around what was being sent back and forth to the agent model. So you have a bit of additional information for debugging purposes. So now that we know that our endpoints work, we can create a front end that uses this endpoint as well. If you check out the repository, I provided a Streamlit application that's very similar to the last tutorial. So I won't go into too much detail, but I just wanted to show you one key difference. So within here, I call it the A2A speaker app, Python. And then I'm just going to paste the code in here. Rather than previously where we would have to look and perform all of the extraction from the response from the LLM, if you recall, this time you just need to do something much simpler. Just do audio URL, look into the data, get the value of the audio URL object, which is exactly what we saw in Postman, where it puts the audio URL within the data object of the response. This is why creating your own FastAPI server version of your agent that's A2A compatible is actually really useful, because you can actually make it a lot more user-friendly for people who are using your agents. All right, so let's actually run our Streamlit app now. So we do Streamlit run apps A2A speaker app, and let's just give this a roll. Here you go. All right, so let's do the following. Convert to audio, like and subscribe to AI oriented. And so you can see it's sending the requests to the agent, and it's very much like the last tutorial. And if I play it,
Like and subscribe to AI oriented.
great, and there you go. So you've got a very similar front-end application, but this time the endpoint that is hitting is different. It's actually the one that we defined manually by ourselves, which provides the audio URL in a much more user-friendly way. And remember, this is now A2A compatible. In our next tutorial, we will make all of the other agents compatible as well. And then I will show you how you can do a multi-agent architecture using A2A rather than relying on the ADK's API server, which is going to be a lot more powerful. If you're enjoying this series, you might want to check out this series here on some very practical MCP servers that will improve your workflow. If you're interested in game development and vibe coding, especially how you can use AI for game dev, you might want to check out this other video over here. Thank you very much, and I'll see you next time.